Alright, as a part of preparation for my upcoming interviews, let's go and read the React official documentation about managing state. Some of these things I will need to probably explain to the interviewer. Maybe I will get a question. So let's go. As your application grows, it helps to be more intentional about how your state is organized and how the data flows between your components. Redundant or duplicate state is a common source of bugs. In this chapter, you will learn how to structure your state well, how to keep your state update logic maintainable, and how to share state between distant components. In this chapter, reacting to input with state. With React, you won't modify the UI from code directly. For example, you won't write commands like disable the button, enable the button, show the success message, etc. Instead, you will describe the UI you want to see for the different visual states of your component: initial state, typing state, success state, and then trigger the state changes in response to user inputs. This is similar to how designers think about UI. Here's a quiz form built using React. Note how it uses status state variable to determine whether to enable or disable the submit button and whether to show the success message instead. Okay, so submit button is cancelled. Now let's see, we have answer, which is nothing. Okay, this is the empty now. We have the error, which is nothing. Okay, let's try numbers. Submit. Good guess, but wrong answer. Try again. Okay, so we didn't get the error, and we got the status. So if status equals success, return, that's right, let's try. I don't know. Denver, I don't know. It's not. In which city is there a billboard that turns air? I have no idea. Let's try reset. Okay, let me actually Google this one. Alright, so the answer for this stupid question, it turns out to be Lima in Peru. Now let's see, this async function, prevent default, set status, submitting. Okay, and then try, await, submit form with the answer, and set status to success. Oh, this is like fetching, similar. Handle text change, yeah, okay, eTarget.value, I understand this one. City quiz, and this is just a text area. Value is the answer. On change is this second function. Disable if status is submitting. Okay, so that's why it sets set status submitting here, and then try and catch. So depending if it is try, then we get set status to success. If not, set status to typing or error. Okay. Well, let's try Lima. That's right. Okay, so I only get this one because the return here for this if statement, if it is correct, is only this h1. Now we should get here like okay, I'm not gonna expand too much, doesn't matter. Ready to learn, yeah. Choosing the state structure. Structuring state well can make a difference between a component that is pleasant to modify and debug and one that is constant source of bugs. The most important principle is that state shouldn't maintain redundant or duplicated information. If there's unnecessary state, it's easy to forget and to update it and introduce bugs. For example, this form has a redundant full name state variable. Okay, so we have the first name, we have the last name, and the full name. And this is correct. This is correct. This is redundant because we can derive this state. We can just say, well, this state equals these two states. And we actually don't even need this setter function. We can just create a normal constable, a normal variable, which is a derived state, which includes the first name and the last name, and then we can use that to display like your name is whatever, and based on that, if these two change, the full name will also change because it's derived. Okay, so let's see. You can remove it and simplify the code by calculating full name while the component is rendering. This might seem like a small change, but many bugs in React are fixed this way. Okay, yeah, exactly, a derived state. So the full name will equal first name plus space and then the last name. Okay. Okay, yeah. Choosing this, how to design the state shape to avoid bug. Choosing state structure. What was the other one? React. Oh yeah, this is too much. This is too much. I'm just gonna go through it. Sharing state between components. Sometimes you want to, I guess this would be about props. You want the state of two components to always change together. To do it, remove state from both of them. Lifting the state up. Move it to their closest common parent, and then pass it down to them via props. This is known as lifting state up, and it's one of the most common things you will do writing React code. In this example, only one panel should be active at a time. To achieve this, instead of keeping the active state inside each individual panel, the parent component holds the state and specifies the props for its children. Yeah, this makes sense. So show, okay, the two cards, only one is active. So the accordion, and it holds this active index, and then it's going to be which is 0, and then it's going to be passed by default. If it's 0, then by default it's this number 1, right? Because the arrays are 0 index based, so 0 is number 1 actually. Okay, we have panel. Oh yeah, and in the panel we pass on show and is active and children and title. So return if is active. We want children. If it is not, show the button. Okay, moving on. Preserving and resetting state. Okay, how much do we have? Okay, when you re-render a component, React needs to decide which parts of the tree to keep and update, and which parts to discard or recreate from scratch. In most cases, React's automatic behavior works well enough. By default, React preserves the parts of the tree that match up with the previously rendered component tree. However, sometimes this is not what you want. In this chat app, typing a message and then switching the recipient does not reset the input. This can make the user accidentally send a message to the wrong person. Yeah, that's right. Chat to Taylor. Hi Taylor. Okay, let me just exclude this one. This here, hi Taylor, and now when we change to Alice, nothing happens. Send to Alice. Send to Bob, and we sent actually to Bob. Okay. React lets you override this default behavior and force a component to reset its state by passing it a different key, like chat, key email. This tells React that if the recipient is different, it should be considered a different chat component that needs to be recreated from scratch with the new data and UI-like inputs. Not switching between the recipient resets the input field even though you render the same component. So basically, I guess we use the map method to render all of these names and buttons to switch. And then using the map method, we add an ID to each element. And this is how React would know by ID. So the ID changed, and I guess then it would reset this. It would reset the UI. Okay, let's see. Set to. We have the contact list. Select contact.name, chat.js. All right, let's just read the theory. Do we have keys here? Oh yeah, chat. Key. So we are passing a key to it. Let's see, are we doing that here? In the previous? No, we are not. Okay, so I was right. This is about keys. Keys that give unique unique thing, 2 elements, so that React knows. Extracting state logic into a reducer. This is interesting. Components with many state updates spread across many event handlers and can get overwhelming. For these cases, you can consolidate all the state update logic outside your component in a single function called reducer. Your event handlers become concise because they only specify the user actions. At the bottom of the file, the user function specifies how a state should update in response to each action. Okay, yeah, so we can edit, delete, add, all based on ID because these are all the same. So let's see that. Show more. Okay. So we have tasks and dispatch. Yeah, this is the default. Task reducer, initial tasks. Okay, handle add task. Text, dispatch, type added, ID, next ID, and type text. Handle change task. Type change, task. This is an argument right here. Handle delete, task ID, we want to take IDs. Okay, return add task, on add task, handle add task, okay, task list, which will display task as tasks, on change that. Yeah, these are all the buttons. And then task reducer. Now this is interesting. This is bread and butter of this. So we want tasks and action here, and then this is one big switch statement. So action.type, okay, case added. What do we want there? We want to return all the tasks, right? ID, action ID, text, action text, done, false, okay. Changed, so in case it is changed, we want to add new one. Oh, no, we want to do a map method. Okay, and I guess to return that. Or no, we want to return the same one. Okay, let's see. Edit. Okay, done. Save. Yeah, okay, so we want to take that same ID. We want this, that we click edit, we want to edit especially this one. So that's why we're using ID. Delete it. We also have to take ID here, exactly. And we want to filter and only delete the one that we selected. Puppet show, delete it. Okay, and then let next ID equals 3. Initial, oh yeah, these are initial tasks. I'm a little bit confused with the next ID. Why is it called next ID? But okay, moving on. Passing data deeply with context. Usually you will pass information from a parent component to a child component via props. But passing props can become inconvenient if you need to pass some prop through many components. Or if many components need the same information. Context lets the parent component make some information available to any component in the tree below it, no matter how deep it is, without passing it explicitly through props. And this is actually what the Redux is doing, the same thing. Here, the heading component determines its heading level by asking the closest section for its level. Each section tracks its own level by asking the parent section and adding 1 to it. Each section provides information to all components below it without passing props. It does that through context. Okay, let's see. So what do we have here? In app.js we have a section, we have a title, we have another section with the heading, another section. Okay, so these are nested elements. Let's see the section itself. We have the level, use context, okay, and the section, level value, level +1, level context, okay, and here we have again the level and switch, oh, okay, so this is a switch statement. So if this is like a level 1, level 2, level 3, level 4, like display smaller and smaller text, and if there's no level, throw an error. right? And then we are defining levels here manually. So level plus 1. And then children, I guess, as each child is rendered, it will add one more level to it. Oh yeah, this is just default. Okay, I think I understand this. Scaling up with reducer. Oh yeah, combination. Scaling up with reducer and context. Reducers let you consolidate a component state logic. Context lets you pass information deep down. Okay, so with the reducer, we centralized our functions, and with context, we send it deeply into components. You can combine reducers and context together to manage state of a complex screen. This is what Redux Toolkit is doing. It is combining, by default, it is combining reducer and context, but in a much more powerful way. With this approach, a parent component with complex state manages it with a reducer. Other components anywhere deep in the tree can read its state via context. They can also dispatch actions to update that state. All right, we have a same one. Yeah, and for that we gotta have a providers. So this is basically like a context provider, I think. And we're importing that. And let's see, task context. Yeah, this is a reducer inside. So creating context. Use reducer. Okay. Return. Oh yeah, here it is. Here it is. Task reducer. So this is a reducer. These are our functions, like cases if the file is deleted or changed, or use task dispatch, return. Okay, I don't quite understand why these two initial values. Yeah, this is okay. I guess I understand the logic of it, how it works, but if you ask me to like retype it blind, I probably couldn't do it, but I understand the logic and the data flow. Add tasks. Yeah, this is just the basic that is doing calling actions. These are calling actions, and this one is calling two actions on click. So it's an object with two functions. So the one is set text, which is local, and the second one is dispatch, which is dispatching an action into a reducer, which will then be sent with the context anywhere. Task list, map, we have keys here, okay. Yeah, and that's it. This is the similar. What's next? Input with state. Yeah, okay. So I wanted to briefly cover this. And this is it about managing state with React. Just brush off, so to speak.